Good morning, ladies and gents. It's 8:29 Google time, so let us begin our Monday session. As usual, I have a lecture prepared, so I hope you have the coffee in your veins to keep you through the lecture, although it's not that very long, right? As usual, right? Thank you very much for your greeting, Mom Sir. Always feel happy whenever I'm in the home base because reasons, right? Allow me to turn off my screen. So let's roll and present um, my PowerPoint presentation while I ignore the multiple prompts in the teacher chat because of the elevator. Okay, do you see my PowerPoint on your side of the screen, ladies and gents? It should read cellular transport mechanisms. On
Yes,
that
sir.
note, a moment of silence while I connect my Sorry, I was turning off my alarm. I don't know why I put myself to wake up at 8:30, but nonetheless, all right, thank you very much for the prompt. So, we will devote our time this morning to understand the mechanisms by which cells transport substances. We have established in a previous meeting that one of the ways that cells accomplish this is through the use of vesicles, and we will see them later down the line. But for other substances, especially the ones that are very, very important for cellular processes and functions, they're actually transported using a different manner, right? So we will walk through the different ways that cells do that exactly, right? The two types of cell transport mechanisms are labeled as passive and active. So if you notice, they are opposites, right? Passive and active are antonyms. So when you say passive transport mechanisms, as the name implies, the cell doesn't need to do anything special for these processes to occur. They just sort of happen naturally, okay? There is no energy expenditure by the cell. The cell need not expend ATP molecules in order for these to happen. They just sort of do. They happen naturally. The only caveat or limitation of your passive transport mechanisms is that the movement is always unidirectional. They only move down the concentration gradient. And what we mean by that is from an area of higher to lower concentration. So you do this because molecules have innate kinetic energy. They try to move around, particularly if they're in their fluid form, liquid or gas, right? So the molecules move randomly, so there is a greater chance that they will move from an area where there's more of them to an area where there's less of them. So that is just the way things work naturally. You always feel this whenever there is somebody spraying a chemical in the room, right? When you use your insect spray at the home, Lysol spray, or even perfume, right? So let's say on one end of our room, somebody is using perfume, so you first do not notice anything, but as soon as a few minutes elapse, you begin to notice that there is a smell in the room because the molecules embedded in the aerosol will have already spread out from the point where they are where they're concentrated tightly to an area where there's less concentration. The same is true if na mangutot sa room, ma'am sir. So pananglit kun mangutot si Cliff, ang una makatimaho kato yung kalamisa and then magkaanam siya ka spread out. So that's just how things happen. On the other side of the coin, we have what we call active transport mechanisms, which actually require energy, right? The cell needs to put in work for these to be accomplished. That's why they're labeled as active. Now, the advantage of active transport is they can go against the natural flow. And what I mean by that is they can go against the concentration gradient. So they can move something from an area where there's less of it to an area where there's already more of it. They will forcibly do that because you are forcing a molecule to move against the concentration gradient. You definitely need to put in work. Hence the label active transport mechanism. But again, they can move in the opposite direction. So for this morning, we will go through active and passive transport. There are five of them total. Just to emphasize, the direction that passive transport happens is always down the concentration gradient from an area of high concentration to an area of low. Active transport can happen in any direction, but of greater import for the cell, it can force molecules from a low concentration to a high concentration of molecules. Okay, let's roll. The very first passive transport mechanism is also the simplest. This is what I just described a while ago. This is the natural tendency of substances or molecules, especially if they're in a fluid. By fluid, I'm referring to liquid or gas. Those are the two states of matter that we call fluids, correct? Solids are not in fluid form. So, this is the tendency of the molecules in a substance to move from an area of greater to lower concentration. All right? Now, incidentally, movement also happens in solids. So diffusion can happen, but because of the tightly packed nature of solid molecules, it occurs in a very slow fashion. All right? So, as an example, let's say I have here a drop of ink placed in an Erlenmeyer flask. After a while, it will spread out because of the natural tendency for molecules to disperse in a fluid, right? Until such a point that the appearance of the water will look uniformly blue, which means that at this point, the molecules of that substance has achieved equilibrium. It has been distributed evenly across the entirety of the space. The important bit is that this can cross the cell membrane if the substance is allowed by the membrane, because we have already mentioned that it is semi permeable. It allows some substances to cross, but it blocks some substances from crossing the membrane at all. Typically, the most important chemicals are the ones which are allowed to diffuse. You have there the important gases for cellular respiration. So this is the reason why your capillaries are only, I don't know how to pronounce it, capillaries, capillary, whatever. Capillaries are only one cell thick, right? That the gas can freely diffuse to the cells of the body. Oxygen from the blood entering the cell, carbon dioxide from the cell moving into the blood. So that happens via diffusion. The important ions for preserving the electrical potential of cells, sodium and potassium, also diffuse, as do some important nutrients like fatty acids, because fat soluble substances typically can cross the semi permeable membrane because of their polarity. All right. Now, I don't want you to take what I said with just a grain of salt. So, I will be sharing a link, right, which I found very, very helpful. I will be sharing it here. So, for those of you who are using computers, you can access that link. For those of you using cell phones, I wouldn't suggest that you do so because that might make it difficult for you. So, you can just run this simulation at any time you want, because when I upload this later in the LMS, you can freely access the link, right? But this will be helpful for our purposes this morning to concretize what I've just talked about, right? So, we have instructions here for side A. You set small and medium molecules to 5, set large to 0, and for side B, all 0, and we set the temperature to 30 degrees and run the sim for 30 seconds, right? I'm going to do that now. So let's see what we can get, right? Small 5, temperature at 30. Take note that the small molecules are designated with a red dot, the medium molecules with a yellow dot, and water molecules with a blue dot. So let's run the sim for 30 seconds and we'll see what happens, which mathematically is expressed in the graph on the right, right? So if you notice they are moving, the kinetic energy of the molecules allow them to move, right? So let's give it a few more seconds to see if something worth noting happens. And we've just about reached that. So when we first started out, you will have noticed that if you were particularly keen, that the molecules were concentrated on the left side of the beaker, and there is a sort of barrier between the two. This represents a semi-permeable organic barrier, right? The cell membrane is something that um, a permeable membrane is omnipresent in nature, right? In other words, when we talk about cells or living organisms, the membranes that they have are all semi permeable. So it allows some substances to cross. So if you notice, at 30 seconds, a lot of the small molecules have already crossed to the other side. They have diffused, in other words, right? If we continue to run this for a big length of time, we can appreciate that the graph will attempt to reach a middle point. That will mean equilibrium. Now, if you notice, the yellow molecules haven't moved that much, but some have made it into the other side because, of course, they're a bit larger. The important bit about here is that over time, the concentration of a substance normalizes across the entire space because of diffusion. Now, let's say we turn the dial up to 11 by increasing the temperature to 50 degrees, right? So that's in the third bullet here. We will rerun the sim for 30 seconds, but this time at a higher temperature than normal. That was degrees. Let's move it to 50. So what do you see? Let's run the sim. The first immediate difference is that the molecules are behaving like grabe ka warla, ma'am sir, no? Because heat confers greater kinetic energy. That means boiling water will have the molecules rushing compared to normal temperature water or cold water. If you notice, the graph has also tried to reach the middle a bit quicker. We can also appreciate that there is more of the molecules that have diffused through the membrane to the other side. Again, this is because of greater kinetic energy. That means the motion of the molecule is also quite fast, right? That means, ladies and gents, that aside from the size of the molecules, other factors can come into play to change or alter the rate at which diffusion happens. And one of the most obvious is the heat, right? In addition to other stuff like pH, viscosity, and the like, right? The other most important bit about passive transport is the second process. So actually, if at first you will try to look at the description and state that's just diffusion of water, exactly, right? Osmosis is just the movement of water from one side of the membrane to the other. There is something, however, special about water because it will attempt to normalize the concentration of substances that cannot cross the membrane. That means if a substance, for any reason, cannot cross the cell membrane, water is the one that equalizes the concentration in and out of the cell, which means that it can move in or out of the cell in an attempt to balance the concentration of a substance, which is what you see over here, right? Take note that the water still moves down its own concentration gradient for where there's more water to where there's less. But another dimension is that it is also moving from an area where there is low solute concentration, more water, less solute, to an area of higher solute concentration, as is what you can see here. Because again, it will attempt to dilute the solution as much as possible since the other molecule cannot cross, right? This is important because some molecules truly cannot cross the cell membrane, so it's left to water to balance things out. Let's try to run the simulation with only large and medium molecules, just to give you an idea about how this works. And let's say we're going to have the temperature at 40. The large molecules are quite obvious, they're gray circles. So let's run the sim. Pause. At this juncture, you will notice that there is a greater density of water molecules on the right side of the screen. Let me reset it for you, okay? And pause immediately. There we go. If you notice, on the right side, water is heavily concentrated, as represented by the blue molecules, and you have fewer on the left side. But let's see what happens if we resume the simulation. The water will try to balance the solution by moving to the A side of the field. This is so that the concentration of the molecules there can be more or less evenly distributed so that water moves out. If we pause at this moment, we will see that water has moved from left B side to letter A, right? I hope you appreciated that. If not, ladies and gents, you can always rerun the sim during your free time and try to tweak the parameters so that you'll be able to appreciate exactly how diffusion happens. Okay, let me go back to my screen. So the answers here are to be found if ever you will run the simulation. So take note, if you have free time, you might want to do it all by yourself, right? This leads to a very special reactivity of the cell because of the way water behaves, right? The tonicity of a fluid is what we call when we refer to how exactly how much concentrated or diluted a solution is compared to the cell, right? And we have three terminologies for that. We have hypertonic, hypotonic, and isotonic. The iso is a prefix which means the same or equal. So this is easiest to understand. When you say isotonic solution, the concentration of solutes both in and out the cell is more or less the same. So does diffusion happen still? Yes. The diffusion still happens both directions, in and out. Because remember, even if it has achieved equilibrium, the molecules still possess kinetic energy. So they will continue to move about randomly. But the rate at which they move is equal in and out. So we can say that the net movement is zero, although the molecules still diffuse normally, right? So in an isotonic solution, a cell will have no effect whatsoever associated with it. The dramatic effect happens when a cell is exposed to a hypo, or a solution that is less concentrated than the cell, or a hypertonic solution, or a situation in which the cell, rather the fluid around the cell has a greater concentration compared to the cell, right? So what this means is that water in a hypotonic solution will attempt to enter the cell instead because it is less concentrated outside compared to the cell's insides. The reverse is what will happen in a hypertonic solution. Because the concentration outside is greater, water will attempt to move out to balance the large amount of solutes out there. In a hypertonic solution, therefore, a cell will shrink as it loses water. In a hypotonic solution, a cell swells as it gains water. In very extreme scenarios, this can cause the cell to either lyse or burst, right? Which means that as much as possible, we will want to achieve an isotonic state. Now, who here are familiar with intravenous fluid? So, ang dili stem, ang tawag nila ana kay dextrose. Yeah, stem man tamam sir. So IVF atong tawag no. The IVF you see in hospitals are actually isotonic, hypotonic, or hypertonic as the needs demand. Like for instance, if the client is dehydrated, we want water to move into the cell. So what is typically given to the patient is a hypotonic solution. If however we want to pull water from the cell out into the bloodstream, let's say in cases where you have edema or water retention or low blood pressure, so you need to increase the blood pressure so that the heart can pump effectively, you want to pull water from the tissues back into the bloodstream. So in that case, you use a hypertonic solution. If you want to keep the balance, you provide an isotonic solution instead. Now, in addition to the medical usage, tonicity has also an impact on, food in general, like the preservation of food using sugar and salt, like dried fish or jams and pickles, for example, are achieved because of the way osmosis happens, right? Using sugar and salt, we will create a hypertonic solution for the cell, which pulls moisture from the cell out into the surrounding space. This is why dried fish are smaller, shrunken in size compared to the real fish, right? The same is true for things that are preserved in jams, right? They're a bit smaller than the regular counterpart because the moisture has been pulled from the cell. Any question before I proceed?
None so far, sir.
Thank you very much, ma'am. None. What mo may question, ma'am sir? Ang only class nung sige ask na ko question kay 4P. Sa tanan akong klase, ang 4P ko like grabe mo question, which I also appreciate, right? So I hope that you're following through despite the lack of no question. The third and final passive transport technique is facilitated diffusion. This is also called assisted diffusion or facilitated or assisted transport. The reason why it's called that is because we have a helping hand here in the form of protein molecules on the surface of the cell. These proteins are labeled as membrane or surface proteins, and they have a special function. They assist the movement of some molecules that cannot cross the cell membrane because of their composition or polarity, right? So the same rules apply. The movement is still down the concentration gradient from an area of greater to an area of less concentration. But the only difference is that you use proteins to achieve the goal because these molecules cannot freely diffuse. This is useful if, because of their solubility or polarity or composition, they cannot cross the membrane, right? I have a picture later to show you that will, I think, is a better picture for facilitated diffusion. Unsa example sa facilitated diffusion, ma'am sir? Kanang elevator, ma'am sir, mo na siya example no nga naa tas ubos daghan kita didto kinahanglan ta mosaka sixth floor kay kapoy kig saka. Umaw na siya. We move from an area of greater to less concentration, the ground floor. Then we move to the sixth floor through the use of an elevator nga gi-off ni Sir Tejo kay what she kwenta. Anyway, let's proceed. Passive transport requires no energy expenditure on the part of the cell, but the limitation is it is unidirectional, right? It can only move from an area of higher solute concentration to an area of less solute concentration. But again, the cell need not work for these processes to happen. Okay? After equilibrium is achieved, does diffusion no longer happen? I mentioned the answer in chat, so let's see if you are aware of the answer. The second one is, can particles diffuse in a solid medium? I also mentioned the answer in chat, so we'll just have to see if those who listen can actually pick that up. Which leads us to active transport processes, right? Because of the name, these are processes which require energy as part of the budget. The first type is just active transport. This is the picture I'm referring to. You have here a comparison between diffusion, right? The circular purple molecules are moving into the space in which there's less of them, right? You also have facilitated diffusion. So the triangular and the blue molecules are also moving towards a space of less concentration, but with the help of either a protein channel, which serves as a passageway, or a protein carrier, which sort of piggybacks the molecule so that it can cross. These are two examples of membrane proteins that assist the process, right? What about active transport? So take a look at the image. You will see there that the square molecule, the diamond one, the dark yellow molecule, is greatly concentrated inside the cell and less concentrated outside. So normally, diffusion will happen in this direction because of the concentration gradient. But what if the cell needs this inside? Since it's going against the natural flow, it will utilize adenosine triphosphate to forcibly pull those molecules inside. So again, we are moving against the concentration gradient from lower to higher concentration. Why would the cell want to do this? There are many occasions. Number one, a cell needs absolutely more of a substance. So it needs to forcibly take it in. The other is if a cell wants to forcibly be rid of a substance, it wants to push it out. The third one is if diffusion has happened and equilibrium has been achieved. This means that the molecules on both sides of the membrane will remain as is concentration wise. So if the cell needs to accomplish one or two, it will absolutely put in work in order to get those molecules in or out where needed, right? So that is the virtue of active transport. They need to get that molecules, or they need to get those molecules out past the concentration gradient. Therefore they need energy to accomplish this. All right, why do I have blank spaces in my PowerPoint? The very last one, ladies and gents, is bulk transport mechanisms, so named because we are moving things in bulk, dinaghan. Think of this as a Pac-Man scenario where the cell gobbles up food, right? This is the mode of transport utilized by cells when they need to move very big molecules. Now, because of the way that's structured, they also need energy to accomplish this, right? Now, when we looked at vesicles before, we're actually referring to a form of transport that is part of bulk transport, right? So let's say the cell wants to get these large molecules inside. Uh, a portion of the membrane will invaginate to accommodate that substance, and a membrane will form around that space. So the cell is forming a vesicle to contain this material, right? Once it has done with it whatever it needs to do, it will also exit out of the cell in a reverse fashion. The vesicle will fuse with the membrane and throw it out. Based on the direction of travel, the process is called endocytosis if it is moving in to the cell, or exocytosis if it is moving outside the cell. So take note of in and exit. That might help you depending on the state of the substance being taken in or out. If it's a solid molecule, we call that phagocytosis. So it's like the cell eating something, right? And if it's a liquid molecule, we call that pinocytosis, or the cell sort of drinking, right, to get that thing inside. Okay? So please take note of that. A good example of phagocytosis is this lymphocyte or white blood cell eating up bacteria that it has come in contact with. So it will use pseudopodia, extending its cell membrane to latch onto those bacteria and pull it inside, whereupon it will create a vesicle housing that bacterium and fuse that with a lysosome so that those contents get dissolved. Right? This is the primary function of your macrophages, those white blood cells that patrol throughout your body to attack any bacteria that they come in contact with. Right? As a bonus activity, I will share to you another resource, not this one, this one. I will share it in chat as well. Okay, for those of you who have computers, you might want to click on that. But for those without, you can just do this in a later date, right? So I have here, I found this very helpful, Ma'am Serna. So this one is not a simulation exactly, but it's just more of a walkthrough. So you have here substances on the upper portion of the screen and an image of the cell. Then they're slightly quivering, Pagyud, right? If you click on a substance, it has a short description of what happens, as well as it shows you the specific type of transport that is occurring. For example, if I click on oxygen, there is a diffusion into the cell, right? Take note that oxygen is carried in the blood, so it's in great concentration in the blood. Once it reaches the capillaries, it will diffuse into the tissues of the body. Carbon dioxide is found in greater concentration inside the cell because it is a byproduct of cellular respiration. So it diffuses out into the blood. Glucose, sugar, is taken into the cell via facilitated transport, right? You need a molecule which is typically um, triggered by insulin so that glucose moves inside. Potassium and sodium diffuse facilitatively. They go through membrane channels, right? potassium, and sodium. However, once the equilibrium has been reached, ladies and gents, they are now transferred via active transport. So let's see if you can pick that up. So mo diffuse sila, right? But later on, parihaaning sodium ug potassium, gina-exchange na sila. So na active transport. Water can freely diffuse, excuse me, via osmosis. My God. And you have enzymes transported via bulk. There you go. So that was a form of exocytosis. Enzymes manufactured in the rough endoplasmic reticulum are now taken out into the cell. So I want you to go through that because it's quite helpful, right? This might help you if you're more the visual type of learner. You can actually learn through that. And on that note, Mama Sir, I think I'm done, which is so anticlimactic. Do you have any questions for me? Because that's it. That's all I have, and I'm done. No
Okay, sir.
questions? Si Karil lagi sige yung none, sir.
None
Si
at the
Kar si
moment, sir.
si Karil ug si Crizel lagi na yung sige none, sir. Sila ang twinsies. Incidentally, do you na mo sa usa ka room, Karil and Crizel?
No,
Wala,
sir.
sir.
Dili mo friends kaayo. Okay,
Dili,
No,
fine.
sir.
sala, sir.
Sana all the cooking house, no? All right. We actually have an experiment to concretize what we've found out this morning, Mom Sir, but I am honestly not sure when we can stage that experiment because let me see. Next week is exam week. So no exam for bio, but yeah, we can. This week on Wednesday and Thursday I will stage the practical test. So we can't have the experiment yet. On the third week of October, that's the exam week. On the last week of October, that's UN month. So I'm not sure exactly what's going to happen. So I'm just pegging that off as really not sure. Then the first week of November, I'm also really not sure what's going to happen because November 1 is I think it's a holiday, right? I'm not sure with 2, but I'll just wait. So whenever there's a free area, we can insert this somewhat. So perhaps we can move in November. We will be using November to learn about that experiment. So two experiments on November, one for cell transport and one for DNA. Right? Yeah. Let's have that November. So nothing pending as of the moment. If you have no questions, ma'am sir, damn, there's still a lot of time left. But I'm
Sir,
done.
excuse me,
Yes,
sir.
go ahead, ma'am.
Regarding sa concert ba sa exams, ang tulo man jud ka science subjects, sir, no?
Wala
Wala
mi, ma'am.
jud.
Yes. I've
Kay
already conferred with my teachers.
naki-clarify to akong concert ba kay ana to what kinsa daw to nga teacher, sir, nga murag naa daw sila but okay, sir. Thank you, sir.
Oh, wala, ma'am. Sure jud ko. Yeah.
Okay, sir.
Base nang hulga ra to ang teacher ba. Ni ana ra sa ilang klase nga mag-exam ko han eh. Ang ending kayo, wala, surprise. Ana dayon ba?
Hadlok-hadlok ra,
Oh,
sir.
hadlok
Okay, sir.
hadlok. So
Thank you,
so
sir.
wala, ma'am sir, no. Wala exam. I have conferred with all of my subject teachers for grade 12 and arts and design. They will have no exam because they among the grade 11 had the exhibit, which is funny, no? Rube Goldberg sila nag-exhibit pagin sila. But anyway, that's arts and design for you, right? So the rest, earth science, if you have friends in grade 11, they will push through with exams. No, earth science, earth and life will have their exams as usual. Only grade 12 because we're badass. That's it. If you have no questions, guys, that's it. Bye. See you around. Have a great day. Enjoy the rest of
Thank
your
you,
day.
Bye,
sir.
sir. Thank you,
Happy
sir.
Monday.
Thank you, sir. Bye,
Bye,
sir.
sir.
Yes,
Bye, sir.
Jasmine. Jasmine, you have a question. You can go, but Jasmine, do you have something? Miss Chu? Jasmine? Yes, ma'am. You're
Sorry,
raising your
sir,
hand.
sorry, sir. Napislitan, sir. Napislitan.
I joke, Rodena. Sige, bye.
Bye,
Bye,
sir.
guys. See you
Bye,
around. See you
sir.
around. Have a